In this example, we are going to use our graphing calculator to do some logarithmic regression. So I'm going to take this table that represents age and the amount of sleep required. I'm going to enter these ages in under L1 by hitting the stat and then selecting edit. I'm going to enter under L1, which if there's something in there, I can hit clear and enter when I highlight L1 at the top of the list. So I'll highlight L1, hit clear, enter. That way I can enter in these values for X. And then I'm going to go over to L2 and put in my Y values that represent hours of sleep. So we have age and we have hours of sleep. And now we want our calculator to make a logarithmic regression equation for us. So we're going to hit the stat button again, and then we're going to go over to calc, and we want to be careful to select ln regression and not one of the linear options. So if we go over to calc, on my calculator it is option number 9, and that is on a TI 84 plus. You want to look for whatever one says ln regression, and then once you hit that, you're just going to hit enter a bunch of times. It should say L1 for your X list, L2 for your Y list, and then if you hit enter, it should produce an equation, and it tells you that you're going to write it as a Y equals A plus B ln. So for our A, we're going to round to the nearest tenth, so it should be 17.3, plus our B is actually a negative, so we're going to do minus 3.3 ln of X. For the next part, we're going to use what we just found using our calculator to find the number of hours of sleep required by a 35-year-old. Now we can look at this table. We don't have a 35-year-old on it, but we see a 22-year-old sleeps 7 hours and a 45-year-old sleeps 5 hours. So when we plug in something around 35, we should get something between 7 and 5 hours, we would think. So let's figure out what that answer would be. So we're going to plug 35 in for X and see what Y, the number of hours of sleep required, is. So I'm going to grab my calculator. I'm going to do Y equals 17.3 minus, I'm going to use the ln button on my calculator, which is toward the bottom left, and I'm going to plug in ln of 35 and round it to 1 decimal place. So the Y value we get there is 5.6, and we need to put units on this. This is 5.6 hours of sleep, which makes sense according to that chart that maybe a 35-year-old would need about 5.5 hours of sleep, just looking because it's somewhere between 22 years old and 45-year-olds. So that answer of 5.6 hours looks good. The next part says, algebraically find the age of a person. So we need to find X this time. Find the age, X, to the nearest tenth. That requires 12 hours of sleep. So we know Y is 12 hours. Our output is 12. And we want to figure out what age are we plugging in. So we're going to set 12 equal to 17.3 minus 3.3 ln of X. So we can look at the chart and see, well, 14 hours of sleep is for a 3-year-old, 10 hours of sleep is for an 8-year-old. So we're probably looking at somebody between 3 and 8 years old that needs 12 hours of sleep. And we're going to use our equation and solve for the log to see what X value we actually get. So we want to solve a logarithm, which means we want to first isolate the log, get it on one side by itself, and then we're going to use base E to get rid of the ln. So I'm going to get ln on one side by itself. So first thing I want to do is I want to subtract this 17.3. 12 minus 17.3 is going to give me a negative 5.3 equals negative 3.3 times ln of X. So I definitely still don't have ln ln of x by itself, it's multiplied by negative 3.3. So I want to divide both sides to get that ln by itself. So I'm going to plug into my calculator, negative 5.3 divided by negative 3.3, and then I'm going to hit math, enter, enter, to reduce that fraction. And when I do negative 5.3 over 3, negative 3.3, it's reducing to just be 53 over 33. And now we finally have ln of x by itself. So your first step to solving logs is to get the log on one side by itself. And the second step is to use the exponent to get rid of the logarithm. So I'm going to use base e on both sides. That way e raised to the ln of x is going to cancel out, and I'm going to have x by itself equals e raised to the 53 over 33. And now I'm going to use my calculator. I'm going to use second ln on my calculator, brings up the e button. So I need to raise e to 53 over 33 and round to a tenth, nearest tenth. So I'm getting x equals 4.98. And since that 8 is there, we'd round the 9 up. So we're getting 5.0. And our units on it is years old. So a 5-year-old requires 12 hours of sleep, which, hey, if we check it compared to the chart, 5 years old is between this 3 and 8-year-olds, which got between 14 and 10 hours. So a 5-year-old, that seems reasonable. Of course, we wouldn't want to get out 35-year-olds because we already said 35-year-olds only require 5.6 hours of sleep. So 5-year-olds seem reasonable. So again, solving for that ln, you isolate it. You want to get the ln on one side by itself. And once you do, you raise it from a base e because e and ln cancel since ln is really log base e.